So we're going to look at this problem that involves relative extrema, relative max, or relative min. So we're going to look at this example. I want us to find the value of the derivative at each relative extremum shown. So I'm going to give you the function f of x is 9x squared minus 3 over x cubed. And now I'm going to give you the graph so you can see the relative extrema. The extrema is right here at this point, 3, 2. And then the graph is going to look like this. And then kind of tapers off slowly there. Okay, so I've got to find, first thing, I need to take my function and find the derivative of it. We're going to have to use the quotient rule to find this derivative. So low, the derivative of the top will be 18x minus the top times the derivative of the bottom all over the bottom squared. So it looks like f prime of x is 18x to the 4th minus 3 times 9 is 27 x squared minus 3 over x to the 6th. I can factor out an x squared out on the top and cancel with an x squared in the bottom. So 18x squared minus 27x squared minus 3 over x to the 4th. And then I can simplify the top a little bit. It'll be minus 9x squared plus 81 over x to the 4th. And they wanted me to find the derivative at this relative, maximum. So if I look here, x was 3. So you're going to plug in 3 into your derivative, f prime of 3. And if you plug in 3, you'll see that you get 0 in the numerator. So f prime of 3 is going to be 0. So let's repeat that again, but for a different problem now, different function. We're looking at y equals sine x. And here I have two relative extrema values we're going to look at. So we have 0 here and here. And then, oh, no. Pi over 2, it's 1. 3 pi over 2, it's negative 1. So the graph looks like this. It's a repeating graph there. And my two extremum values, this first one, pi over 2, 1. And then my relative minimum will be 3 pi over 2, negative 1. So I'm going to take my function and I'm going to find the derivative, y prime. The derivative of sine is cosine. And then we're going to plug in, so maybe I'll plug in when x equals pi over 2, what's our derivative going to be? Cosine pi over 2, that's 0. And when x equals 3 pi over 2, our other relative extrema, y prime, will be cosine of 3 pi over 2, which is also 0. So I'm getting my derivative of my two relative extrema is 0. So then you might ask, in these last, two examples, always at my relative extremas, my relative maxes or my relative minimums, the derivative was 0. Does this always happen? And the kind of short answer is yes, provided, yes. So before we get into that though, I want to write this definition. We're going to say let f be defined at C if f prime of C is 0, or if f is not differentiable at C, then C is a critical number of f. So either your derivative needs to be 0 or your derivative is undefined. And so then we have this theorem that says just what we learned from this example that we looked at. It says if f has a relative min or a relative max at x equals c, then C is a critical number of f. So if you have a relative min or a relative max, it has to correspond to a critical number.